Just imagine this. What if Earth isn't the best place to live in the entire universe? What if out there, beyond the glittering belt of stars and dark voids, exist worlds more perfect than our own? Not just habitable, but superhabitable. These are planets that might be more suitable for life than Earth itself. It's a bold idea, one that challenges everything we've assumed about our planet being the gold standard for life. But now, scientists are starting to seriously explore this possibility, and what they're finding is astonishing. The term superhabitable may sound like science fiction, but it's grounded in solid research. Scientists coined the term to describe exoplanets that have the right ingredients to support life, but do it even better than Earth. Think about that for a second. A planet with better air, more stable climates, richer biodiversity, and longer-lasting habitability than Earth. That's not just a fantasy anymore. It's a real scientific pursuit. And space agencies like NASA and ESA are now hunting for these worlds using some of the most advanced telescopes ever created. So what exactly makes a planet superhabitable? It's not about being an Earth clone. In fact, a planet that's just like Earth may not be ideal. Scientists believe a truly superhabitable world might be slightly larger than Earth. Maybe around 10% more massive. Why? Because it would have stronger gravity to hold onto a thicker atmosphere, providing better protection against harmful space radiation and more stable weather patterns. That thicker air might even make flight easier for any creatures living there. Then there's the star the planet orbits. Earth revolves around a G-type yellow star, our Sun. But superhabitable planets might do better around a K-dwarf star. These stars are a bit smaller and cooler than the Sun but last far longer, up to 30 or even 70 billion years. That gives life on their planets more time to evolve, grow, and thrive. On Earth, it took nearly 4 billion years for intelligent life to emerge. Imagine a planet with double or triple that time. But it's not just about time. K-dwarf stars are also less likely to blast their planets with deadly solar flares, which is great news for any fragile life forms trying to survive. They offer stability, millions of years of calm, steady light. That's the kind of cosmic peace that life loves. And because these stars are more common than suns like ours, it means there could be way more superhabitable planets out there than we ever thought. Let's talk temperature. Earth's average temperature is about 15 degrees Celsius. That's livable but not necessarily ideal. A superhabitable world might average around 25 degrees. That's warm but not too hot. It could mean larger areas of lush forests, wider tropical zones, and more rain, leading to a higher chance of biodiversity. Life thrives in warmth and water. More of both means more ecosystems, more food chains, and more room for intelligence to arise. Water is another key piece of the puzzle. A superhabitable planet wouldn't be a desert like Mars or a water world with nothing but ocean. Instead, it would have a balance: large oceans for climate control, but enough dry land to support forests, mountains, and rich ecosystems. Maybe even more shallow seas and island chains than Earth, which are ideal for coral reefs and life's evolution. Now imagine the gravity. On a slightly larger superhabitable world, gravity would be stronger. You might weigh 10 to 15% more. That would make climbing a little harder, but your body would adapt. Stronger muscles, denser bones. And the stronger gravity would help keep the planet's atmosphere thick and stable. That means less radiation from space, more oxygen in the air, and a safer environment overall. Even a planet's plate tectonics can play a role. On Earth, tectonic activity helps recycle carbon and maintain climate over millions of years. A superhabitable planet with steady, slow-moving tectonics might be even better at regulating climate. Not too many earthquakes, not too few. Just the right balance to keep everything in motion and habitable for longer periods of time. Let's not forget magnetic fields. Earth's magnetic field protects us from cosmic radiation. If a superhabitable planet has a bigger molten core, its magnetic field might be even stronger, creating an invisible shield around the entire planet. That's another layer of protection, another reason life could thrive more easily. But what about moons? Earth's large moon helps stabilize our planet's tilt, giving us seasons and a stable climate. A superhabitable world might have more than one moon, or a larger one that offers even greater stability. Multiple moons could also create beautiful night skies, but more importantly, they could help regulate tides and prevent climate chaos. So far, astronomers have identified several candidates that might be superhabitable. One of them is KOI 5715.01, an exoplanet about 3,000 light-years away. It orbits a K-dwarf star and seems to be in just the right spot, the habitable zone. Another candidate, Kepler 442b, lies 1,200 light-years away and has a surface temperature just warm enough to support liquid water. It's 30% larger than Earth and might have an atmosphere thick enough to support life. But perhaps the most exciting candidate is Teegarden's star B. It orbits an ultra-cool red dwarf just 12 light-years from Earth. It's one of the closest potentially habitable planets we've ever found. Scientists believe it might have the right temperature, gravity, and conditions to be a serious superhabitable contender. And because it's so close, we might be able to study it in more detail very soon. Of course, there's one big challenge. Even if we find the perfect superhabitable planet, we can't go there, not yet. Our fastest spacecraft would take thousands of years to reach even the nearest stars. But that doesn't mean we're stuck. With next-gen telescopes like the James Webb Space Telescope and future projects like LUVOIR and HABEX, we can scan these worlds for signs of life, like oxygen, methane, or even artificial lights. What if we discover glowing cities on the night side of a distant planet? Or a thick oxygen-rich atmosphere full of life? These are not just dreams anymore. They're questions that astronomers are actively exploring. And each new discovery brings us closer to answering one of humanity's oldest questions. Are we alone? In the vastness of the universe, the idea that Earth is the best we can hope for might be outdated. Nature may have built something better. A planet more stable, more fertile, and more alive. And while Earth is our home, it may not be the ultimate home for life. The search for superhabitable worlds is more than just science. It's a philosophical journey. It forces us to rethink our place in the cosmos. Maybe Earth isn't the blueprint, but just one version among many. A stepping stone toward understanding what life truly needs to thrive. Maybe, just maybe, somewhere out there is a world that makes Earth look primitive. A world where life has blossomed in ways we can barely imagine. But if these superhabitable worlds are out there, how would we even detect them? It turns out we've already found a few promising candidates. Scientists have identified dozens of exoplanets that fit some of the key criteria for superhabitability: right size, right star, right distance, and potential atmospheres. One of the most talked about is Kepler 442b, a rocky exoplanet about 1,200 light-years away. It's larger than Earth and orbits a stable orange dwarf star. Conditions there might be more supportive of life than even on our home planet. While we haven't confirmed anything yet, it's one of the closest matches to this concept. Another fascinating example is Kepler 452b. While it orbits a star much like our Sun, what makes it intriguing is the idea that it's older than Earth by about 1.5 billion years. That extra time could have allowed life to evolve longer, potentially reaching advanced stages we can only dream about. If there's a civilization there, it could be far ahead of us, perhaps even watching us while we're still struggling with spaceflight. These older superhabitable worlds could be treasure troves of alien evolution, rich in biodiversity or even complex societies. Now let's dive into something even more mind-bending. The idea that life on superhabitable worlds may not just be more likely but also more diverse. Earth's biodiversity has been shaped by countless factors: climate, plate tectonics, asteroid impacts, and more. But imagine a world with fewer mass extinction events, a more stable climate, and wider habitable zones. Evolution could proceed with fewer interruptions, resulting in ecosystems that are far more complex. Creatures we can't even imagine could roam its surface, adapted to environments much more comfortable than anything we've seen. Some scientists believe these planets could have thicker atmospheres with more oxygen, which would allow for larger and more energetic life forms. On Earth, oxygen was a key factor in the rise of large animals. If a planet has even more of it, and if the gravity is just right, not too strong, not too weak, it could support life forms that are taller, stronger, and maybe even smarter. Think of massive forests with trees stretching into the skies and creatures with biological capabilities beyond our comprehension. It sounds like science fiction, but it's grounded in real science. And what about water? Earth is sometimes called the blue planet, but some superhabitable worlds could be even bluer. They might have more shallow seas distributed across more of the planet, creating optimal environments for marine life to flourish. Coral reefs could span entire continents, supporting a web of species so complex that it makes our own oceans look barren. These vast water bodies would also regulate temperature more efficiently, creating a planet that rarely experiences harsh climate swings. The role of a planet's axis tilt and rotation speed also plays a huge role in how habitable it is. A perfectly tilted planet with a moderate rotation rate can avoid extreme seasons and temperature differences between day and night. This means more areas remain within a stable temperature range year-round. Superhabitable planets are theorized to have this perfect balance, allowing more regions to support life at all times. Earth has deserts and icy poles, A superhabitable world might have far fewer of these extremes, making it more uniformly supportive of life. Let's talk about volcanoes, not just the destructive kind but the life-giving ones. Volcanic activity recycles nutrients and helps shape continents. A planet with well-regulated plate tectonics could maintain high levels of biodiversity. Not too much activity to be dangerous, not too little to become stagnant. Earth's tectonics play a big part in its long-term habitability, and a superhabitable planet would likely have similar, or even better, geological dynamics. These planets may even have more consistent magnetic fields, shielding them from stellar radiation more effectively than Earth does. When scientists think about where to point powerful telescopes like the James Webb Space Telescope, these superhabitable worlds are becoming top targets. The search isn't just for any planet in the habitable zone anymore, it's for planets that check more boxes, ones that are statistically more likely to host life. These include planets around orange dwarfs, those with stable atmospheres, and those with signs of water vapor or oxygen. In the next few decades, we might actually detect biosignatures, chemical fingerprints of life, on some of these worlds. And once we find them, the question becomes, should we go there? Interstellar travel is still a far-off dream, but we're laying the groundwork now. Technologies like fusion propulsion, light sails, and even theoretical warp drives are being studied seriously. If one of these superhabitable planets turns out to be not just habitable but already inhabited, it would be the biggest discovery in human history. It would forever change our understanding of life and our place in the universe. Contact, if possible, would spark debates and excitement beyond imagination. But there's also the possibility that life on these planets doesn't look anything like ours. It could be based on different chemistry, maybe silicon instead of carbon, or operate in environmental conditions that would kill us. Superhabitable doesn't necessarily mean Earth-like in every detail. It means better suited for life in general, not just human life. That opens up the possibility of encountering truly alien ecosystems, ones that challenge everything we thought we knew about biology, evolution, and survival. And here's a philosophical twist. What if we find a superhabitable planet and discover that it's pristine, untouched, and full of potential, but with no life? It would raise deep questions. Why did life not evolve there despite perfect conditions? Could it mean life is rarer than we thought? Or perhaps we're just too early in the timeline, and life hasn't had time to emerge yet. These discoveries could challenge not only our science but our sense of purpose. It might inspire a new mission, not just to explore but to seed life elsewhere. Some researchers even suggest that superhabitable worlds could be the future home of humanity. If Earth becomes uninhabitable due to climate change, nuclear war, or other disasters, these planets could be lifeboats. Terraforming Mars is one thing, but finding a planet that already offers a better environment than Earth is the ultimate goal. We wouldn't have to build domes or underground shelters. We could walk under alien skies and breathe the air of another world. That idea is both thrilling and humbling. The more we learn about these worlds, the more we realize how fragile and unique our own planet is. Earth might not be the best planet in the universe, but it's the only one we have right now. The hunt for superhabitable planets isn't just about escape. It's about understanding the full range of what's possible. By comparing Earth to better examples, we can better appreciate what we have and also strive for a future where humans thrive beyond our own world. In the end, the discovery of superhabitable worlds redefines what we mean by Earth-like. It's not about finding our twin anymore, it's about finding planets that surpass our own in supporting life. These discoveries push us to evolve, not just technologically but intellectually and ethically. We must ask ourselves, if we find a better world, what will we do with it? Will we protect it or exploit it? Will we learn from it or repeat the mistakes we've made here? These are the questions the search for superhabitability forces us to confront. And as telescopes get sharper, missions grow bolder, and data becomes richer, the chances of finding these planets grow every day. Somewhere out there, in the dark between the stars, may be a world more perfect than our own. A place where life blossoms in abundance, where skies are clearer, forests thicker, and oceans deeper. A world that shows us what's possible when the universe aligns just right. And one day maybe we'll call it home. Until then, we look, we learn, and we dream.